Your skin is the largest organ in your body, but how much do you really know about it? The bottom layer of your epidermis is the stratum basale, or the basal layer. This is made up of stem cells that can constantly create and proliferate all of the skin cells that you will ever have in your entire life. These basal cells are making keratinocyte after keratinocyte, which are your skin cells that then rise up through the rest of the layers of your skin. Those keratinocytes from the basal layer then rise up to the next layer, the stratum spinosum, or the spiny layer. Here, those keratinocytes develop these spiny, sticky little tendrils that help them stick together and keep your skin from falling apart. Now that those skin cells are good and locked together, they rise up into the next layer, the stratum granulosum, or the grainy layer. This is where your skin cells lose their nucleus, which means they're technically no longer alive, and it gets replaced by keratin, which is this really tough, flexible protein. That's why it's called the grainy layer. Those skin cells flatten out and rise up to the final layer, the stratum corneum, which is just layer after layer after layer of skin cells held together by this fatty mixture made of ceramides, cholesterol, and fatty acids. Keeps everything waterproof, keeps everything resilient. You know it as a moisture barrier. Let's take a closer look at a skin cell. The life of our baby skin cell begins in the stratum basale, the basal layer, where those stem cells generate a brand new baby keratinocyte. It enters its adolescence in the stratum spinosum, where it gets those spines to help it hold on to its neighbors. In middle age, it reaches the stratum granulosum, where it goes from having a living nucleus to a bunch of that flexible, tough protein called keratin. 4 to 6 weeks later, it enters the stratum corneum, where it flattens out, turns into like a dinner plate shape, and is held together with that fatty mixture of ceramides, cholesterol, and fatty acids. Then finally, our baby skin cell enters old age and falls off and dies. Let's look at keratin, which is that protein that fills up the skin cells in the stratum granulosum and then becomes those corneocytes for the final layer, the stratum corneum. Keratin is this really long, strong, flexible protein. It's actually what your fingernails are made out of, and it's part of what gives skin its strength and resiliency. So what does this mean for you? Isn't science enough? Maybe not. Maybe we need a practical reason. Okay, here's one. As I mentioned, it takes about 6 weeks for a skin cell to go from being born in the stratum basale to falling off of the stratum corneum. That's 4 to 6 weeks where the skin is moving through its whole cycle, which is why you can't really expect instant results from your skincare. What's another reason all of this skin structure matters? Well, let's take a look at how exfoliation works. Exfoliation is just helping to remove some of those dead skin cells on the surface of your stratum corneum. There are 2 types of exfoliation. There's chemical exfoliation, which works to disrupt the chemical bonds between skin cells, helping them break apart and fall off naturally. Then there's physical exfoliation, which is literally just scrubbing at it until it comes off. Here's a question you may be asking. Alli, if skin cells are constantly shedding, why don't tattoos come off? We have only been talking about the epidermis, which is the upper layer of the skin. So this is that stratum basale. This is where those skin cells are being generated, and from here, they're rising up and shedding off. Below that, you have the dermis, which is where your collagen and elastin live. Sort of the scaffolding of the skin. It gives your skin its structure and its bounce. When you draw just on the surface of your skin, even if you dye those cells, they'll fall off in just a couple of weeks. That's why tattoos have to be painful. You need a needle to get that pigment down into the dermis. Cells don't replicate and renew themselves in the dermis the same way as they do in the epidermis, which means with a tattoo, that pigment is permanent. I hope this was helpful. If you're interested in more science deep dives into the science of skincare, be sure to subscribe. If you have any ideas for future videos, any questions you want me to answer, sound off in the comments. I'll see you next time. Granulosum, where it has previously had a living nucleus that is then replaced by all of that flexible, hard protein called keratin.